So we're here in Hellevoetsluis. Apologies for the pronunciation if you are Dutch. It's in Holland, and we're here to meet Igor Kluin, who's the co-founder of a company called Vaan Yachts, which has a very interesting take on sustainability. So the yacht's hull is 6% recycled aluminium. There are PET deck heads, which used to be plastic bottles, all the linen, cork decks. There's all sorts of interesting takes on it, and of course it's a movable feast, so you can get more sustainable. But let's find out how he builds boats. So we're here today with Igor Kluin, who's a co-founder of Vaan Yachts, and he's going to tell us a little bit about the company. So why did you set the company up? Who's it for?
I'm a sailor from when I was 3 years old. I'm a monohull sailor, and then I saw a catamaran lying around, and I thought that's fantastic actually, as long as they would look better and sail better. And be more sustainable. So those are really the three reasons. We want to make it for sailors. We want to look a little better and make it truly sustainable.
Okay, and you've got family, I understand, and you want to just take them sailing.
I have 4 kids, and this idea of having the inside and the outside connected on the same level, which is a benefit of any catamaran. I was raised to be by my father to be a monohull sailor, and catamarans were not sailing, and basically I'm trying to prove him wrong maybe with this.
And the 3 guiding principles are?
Sailing, style, sustainability. So, and we want to make it for sailors, a catamaran for sailors. It's not a racer, but it sure is real sailing. Good upwind angles, good tacking. It has different styling, so that's the second principle. You like it or you don't, that of course is up to you, but it is surely different styling. And then the sustainability is at the core of the company rather than an added green sauce at the end.
Okay, and what journeys have your clients made? Where can we find Vaan Yachts around the world?
Well, we've only built a few yachts so far. So there's one in Sweden, there's one currently crossing the Panama Canal. They go everywhere, and our customers are really from everywhere. So the ones that we're building right now will go anywhere. We build them to go anywhere.
Can you show us around?
Sure.
So what's here? What's this?
So this is the hull of an R4, 42 feet. It's our smallest model, and it just arrived yesterday. So basically the hull is manufactured at one of our 4 hull building partners here in the Netherlands. Holland has a great ecosystem for aluminium yacht building from the shipyard industry. So we have great quality hull builders, and this is how it arrives over water. You can still see the structure, how it is transported here, and we put it in the shed yesterday.
Okay, and tell me about the aluminium on this, because this is it's again one of the core principles of sustainability. The aluminium on this is?
It is 60% post-consumer scrap recycled aluminium. And the post-consumer scrap is very important because it means that the aluminium actually has had a life as window frames, license plates, or traffic signs. If you cut aluminium from a plate, there's also a little waste, of course, the sections you don't use. Some people are inclined and want to include that as well, say, well, that's recycled, but it really isn't. That is still virgin material. It has never served a purpose. So with post-consumer scrap, it is true recycled aluminium that has had a life before. So that proves the circularity of it. I think the big difference between aluminium building and GRP building or composite building is, of course, that we don't have a mold to build from. We just cut aluminium flat plates in all kinds of sections, thousands of sections that are then welded by welders into the hull. So all these parts, it's obviously much more labor intensive that way. But the benefit is it is a much stronger hull. It is much safer, much more rigid. And particularly with a catamaran where the hulls go up and down the waves at different moments, you get a lot of torque and twist between the hulls. And that's where the aluminium really shows its benefit, because it is so rigid. It doesn't do that bending, and therefore it's very, very quiet inside, because normally the interior starts creaking, and because of that twist and turn between the hulls. We don't have that, and that means it's super quiet inside. It also means we can do large windows like this. On the side windows, you don't see that in any composite boat, because there's so much torsion going on that the window would crack. We put real glass in there, which has a much better visibility. It lasts much longer. And we can do it this big because of the aluminium structure.
Okay. So where does that rigidity come from?
Yeah, so the aluminium two hulls are really connected by two main bulkheads. One is in front, behind the mast support. The mast support is connected to it. And on the other side of it is actually another structure. It's called what we call the beam going across. It's like a tunnel attached to the forward bulkhead. Then there's a second bulkhead aft under what we call the roll bar, inspired by the Porsche Targa roll bar. On top of it is the traveler for the mainsail, and on the sides you see these thick bulkheads. So it becomes a circular bulkhead basically, and together with the one in front, we create a very rigid hull.
And what are we looking at in terms of thickness of aluminium? Does it vary around the hull?
It varies around the hull. Up here, for instance, you see 8 millimeters, and then the stringers are 5 millimeters. The top is 5 millimeters. Inside, on the bottom of the hull, we go to 8 or 10. So it varies throughout. It's always a balance between strength, weight, and construction, and ease of construction. You see all these little welts, they create heat, so it disforms the aluminium. So you gotta be careful how much heat you introduce into the material and how thick that material is. So it's a constant optimization there.
So apart from the materials, how does aluminium construction differ to GRP?
Yeah, so obviously we don't work from a mold. A GRP boat is built in a mold layer by layer, and then you pull it out of the mold. Aluminium construction is just, you get all these flat parts that are cut from a flat plate, and you weld them together piece by piece. It's a lot of labor intensive, but of course it results in a very strong boat. And one of the things that is more difficult for us is that we cannot put the deck on at the very end. So normally you have the hull, you put the interior in with GRP, and then you put the deck on, which is very convenient, of course. For us, that's not possible because it is all one structure together, and that gives it that strength. But we solve this, for instance, by leaving certain areas out that are not part of the structure, but then create a bigger gap so we can still install large pieces of the interior going through a big hole, and once it's all in, we put that last bit of aluminium back in. Of course, not part of the structural components, but yeah, very simple steps like that make it still possible to do it quickly.
Okay. So that's the interior is fitted out through this gap, and then the gap is closed?
Correct, yeah.
Okay. So I see there's already some glass wall insulation here.
So certain parts of the boat are very hard to reach after the welding has been completed. For instance, this bridge deck under the saloon that goes to the other side needs to be insulated, but you can't reach it once the hull is done. So during the construction process of the hull, the welding process, we install these red tubes for the cabling going across, and we install the glass wool insulation before actually the welding is put together. It makes it easier for us in the next stage.
So the sustainability angle also affects the propulsion of Vaan Yachts. What do we have here?
So all of our boats have electric propulsion. So the motors are electric drives. There's a range extender that runs on diesel for certain scenarios, but it is all electric drives. Large battery banks, so for the battery banks usually are dimensioned so that for 90 or 95% of your sailing days, you only use the electric. It's just for certain scenarios when you want to get away from a weather system or you have to do a long range motoring, then the range extender basically runs on the diesel, but it is it's not used for, let's say, 90% of your sailing days. In and out of the marina, in and out of the anchorage, you don't need any diesel at all. It's all electric.
Okay. And this is where the electric sail drive is. That's watertight.
Yes.
Should anything happen to it.
Yeah. So it's there are many benefits for electric propulsion. Silence, direct torque. It's really powerful, real quick, but also space. So this little area here on the R4 is all there is to it when it comes to the sail drive. So it's a very silent motor. It can be under the bed as it is here. And it is in a little compartment that has watertight bulkheads on both sides, so that in case anything goes wrong, it is still safe in that little area. Obviously with an aluminium hull, nothing really goes wrong when it comes to holes in the hull. It doesn't happen, but it is still extra safe because of the watertight bulkheads on both sides.
And that bulkhead at the back?
Yeah, pretty much all the main bulkheads in an aluminium in our hulls are watertight at least 30 centimeters above the waterline. So in case anything goes wrong in any segment of the boat, again, it is a very safe hull because it is made out of aluminium. But in case anything goes wrong with a through hull or with a rudder stock, then the watertight bulkheads ensure that that problem is compartmentalized and it will stay in that little area.
And it's got its own bilge pump in there.
Yes, all the sections have their own bilge pumps. There's almost, I think there's 10 across the 42-foot cat. So, yeah. But again, it is a problem that rarely happens because it is such a strong hull.
So what about insulation on the ceiling and the hulls?
Yeah,
on
so
the hulls and
the standard insulation is glass wool. Again, it's a special glass wool that comes from the superyacht industry because it's even lighter than normal glass wool, weight saving. And we can do 5 centimeters standard. We put always standard insulation in, 5 centimeters. And optionally, if you intend to really go to the Nordic regions, which aluminium boats can do very well, then we can add a second layer and it comes up to 8 centimeters of insulation.
Okay, and that's for hulls, ceilings?
Everywhere, except below the waterline. Below the waterline, we don't do any, because there you get some condensation so it can nicely drip into the bilge.
Okay. So this is another R4 in build. How much further down the line than the one we've just left?
Hard to say, but roughly this is about 1 month further down the line in the outfitting stage. Obviously there's a little flexibility, so some parts are a little bit further, some are behind, but roughly this is 1 month into the outfitting stage.
And what has happened? Obviously we see there's some insulation going in.
Yeah, critical part is the insulation has gone in. The paint job has been done. We don't paint the outside of the hull on this one, but the upper deck and the roll bar, everything has been painted. And then everything that happens under the floor, so all the pipes, the tubes, the tank connections are all made in. So this is about ready to take in the interior because the flooring has also been put on. So this is about ready to take on all the cabinets and the interior stuff.
So this is a design feature I haven't seen before. Do you want to talk me through it?
Right, so this is what we call the V grinder, and the grinder comes obviously from the Volvo Ocean Race, like the coffee grinders. So there are 2 winches installed on those, aiming forward. Pretty much all the lines run back under the saloon floor, and then come up here, as you'll see later when we go out sailing, and you control pretty much all the lines. So main sheet, reefing, jib sheet are all controlled from this V grinder.
And that also does for the davits as well?
The davits are actually controlled, the lines come in through the davits and you use the same winches to hoist the boat.
Okay, and the uptake for the davits is kind of in the middle of the arm.
Correct.
So the benefit being?
The benefit actually because we designed the davits to be an integral part of the construction. So as you can see, it is super strong. So you can hoist a pretty heavy tender on this. And then it's pulled up in the middle as you point out. And it has a radius on the inside here, so you pull it snug against the davits. It extends a little bit further out, so it also touches the other tube of the dinghy. And therefore, when you pull it up with these 2 winches, it's all done. There's no need for different lines to the side. It doesn't start swinging. It is snug against the davits, and that's all there is to it.
Okay, so we see the stub keel here. I guess that means it can rest on a beach?
Yes, it can.
Okay, and what about performance? How do we?
Right, so with a catamaran, it's always a balance between, how deep can you go for upwind performance and what do people want in terms of getting close to the beach. It's different for catamarans than for monohulls. For a monohull of this size, a 2 meter depth would be fine. For catamarans, not so much. So we try to strike a balance between drift in upwind angles and at the same time getting close to the beach. We do have a second option. Out of this hollow structure, we can also extend a small sacrificial dagger board. It adds another 40 centimeters of depth and also provides better upwind angles. And it is sacrificial. It's one of the few composite parts that we use on the boat.
Okay, and how is that? Can it be retracted or is it just...
Yeah, no, it can retract and so go up and down, but it stays inside this hull, so inside the keel, so it doesn't go into the hull, so you don't lose any space over it inside.
Okay, and how do you move it? Is it pulleys or...?
It's electric
Of course it's
operation,
electric.
yes. So it doesn't open the hull to any more systems, basically. It's still a watertight hull.
How does she dry out on a beach?
Right. Obviously, as you can see, the keels are made of aluminium. I always have difficulty calling them keels because there's obviously no ballast in them. This is a hollow structure, but it is very rigid. So the boat can rest on them, as it does now. And then the rudder can be reinforced, so beaching is an option. And then the rudders are reinforced with steel inside, so in case it tips a little bit, it rests on the rudder.
Okay, but the idea is it can rest on these. If it needs to rest on the rudders, it can also do that.
Right. All the load is basically coming to this structure, and the rudders are just for balance.
Okay, perfect. So we found out a bit about how they're built. Now we're going to go sailing, because that's what Yachting Reviews likes to do. So like and subscribe if you like the tour, and you'll find our sailing test, the Vaan R5, on our channel, Yachting Reviews.